In this video, we're turning our attention towards an important aspect of writing robust and bug-free code, handling exceptions with try and except. Exception handling is a critical concept to grasp in any programming language, and Python is no exception. We did briefly go over try and except in the calculator project, but this video includes more information on it. So what exactly are exceptions? In programming, an exception is something that occurs during the execution of a program and disrupts the normal flow of its instructions. So that's just basically an error. This might occur when you're trying to read a file that doesn't exist, or trying to convert a string to an integer that can't be converted, for instance. And to deal with these unexpected events and prevent our programs from crashing, Python provides us with tools to handle exceptions gracefully. And that's what we're going to explore today. Now you might be thinking, well, why not just write bug-free code? If a user enters something that's not a number in a program where they're supposed to, you might get an error when trying to convert it to an integer from a string. So, to handle the error, you might just ask them again. The primary tool for handling exceptions in Python is the try except block. Here's how it works. You put the code you want to try executing inside a try block. If an exception is raised or an error occurs while the try block is executing, it immediately transfers to the except block. Let's demonstrate this concept with a simple example. So here we can say print x, which is a value that doesn't exist, right? We don't have this variable. And when I run this, it says name error, x is not defined. But what we could do is we could put this in a try and except block. So here I'll type try, and then the indented code will be the code that you'll try to execute. And then the except block will be what happens if an error happens. So we can say an error occurred. And when we run this, we get an error occurred. So in this example, we tried to print a variable x, which we haven't defined yet. Normally, this would raise name error and stop the execution of our program. However, because we've enclosed our code inside a try except block, when name error is raised over here, it immediately transfers to over here. So instead of crashing, our program prints out an error message and continues with everything else. So what would happen if I were to print end of file and we got rid of try and except, so we just commented out try, unindented this. Whenever there's an error in Python, it immediately stops and nothing else after the error is executed. But when we use this try and except block and we indent this code here, just like this, when you get an error, you can actually just use the except so that the error doesn't interrupt the program and continue to the end. So here we get an error occurred, end of file. So this allows our program to handle unexpected errors gracefully, providing useful feedback or even recovering from the error rather than simply crashing. Now, of course, this example doesn't really make sense because no matter what, x is not defined. But there are sometimes in your program where there are expected errors, mainly from things like users entering wrong values and things like that. Python has several built-in exceptions that you can catch and handle. For instance, when trying to divide by 0, raises a zero division error, and trying to access a non-existent element in a list raises an index error, and so on. In a try except block, you can catch specific exceptions and handle them differently. Here's an example. So let's try some things, and under this print statement, we'll set x equal to 1 divided by 0, which will raise a zero division error. And here we can print non-existent variable, because it doesn't exist. And then we will print this is the end of the try block. Now we can accept, but instead of just accepting all errors, we can only accept zero division errors if we wanted. And if we got a zero division error, we could print you can't divide by 0. And we can have another accept block, so we can have multiple. We can also accept name errors, which happen when you try to access a variable that doesn't exist. So we can say that variable doesn't exist. In this example, when the zero division error is raised, the execution immediately transfers to the first except block, so that's the zero division error one, and you can't divide by 0 is printed. So when we run this, it only says you can't divide by 0. The name error that would have been raised by trying to print this non-existent variable is never reached because the zero division error was raised first by this line of code. So remember, once an exception is caught, the rest of the try block is skipped and Python moves on to the correct except block. So this name error will never get executed. Before this, we just typed except. So only typing except accepts all types of errors. But this isn't always a good thing. For example, if you have a program where the user is supposed to enter a number, but enters a letter. Your program might crash because it'll try to convert the string to an integer but can't, so then you'd use a try and except block and ask the user again in the except block. But if you only typed except, it would fix the user problem, but if you accidentally created any unrelated errors in your try section, you wouldn't know what caused it. So it's always a good idea to accept expected or even intended errors, and all other errors should help you fix your program. So you can include multiple errors in one except statement as well. So if we wanted to accept both name errors and zero division errors, so what you might think you'd do is you'd say name error and then also zero division error, but you have to put them in parentheses. Okay, so now we'll accept both of these errors, and if either one of these errors is raised, then we'll print an error occurred. So now this print statement will print if you encounter a zero division error or a name error, but nothing else. You might be wondering how you can actually find these errors and type them in your except block. So if you're wondering this, let's just say we had a zero division error, but you didn't know what it was called, and you ran x is equal to 1 divided by 0, and let's say we ran this, right? So here we get an error, and you might think, okay, well, let's accept this because I want to use a try except block on here. So you might think, okay, well, how do I accept this? At the bottom here, it always will say the type of error, and then a colon, and then what caused the error. So here you can actually just copy this and put it over here. And so we can say try x is equal to 1 divided by 0, and then accept, and then paste that, and then do whatever you're trying to do. Most code editors highlight the color in a different color than most other things. In VS Code, with my current styling, it highlights all errors with this green color, but it's different for everybody, and just know that it changes the color. If it doesn't change the color, if it's like white or something like that, it's not a correct error. And so it actually auto-completes this here, so I can actually click that and it works like that. Sometimes you have code that must be executed regardless of whether an exception was raised. That's where the finally block comes in. Code inside a finally block always runs, whether an exception was raised or not. Let's look at the code from our previous example. We can add a finally block after the except block. So finally, we can print this line always runs. And so here we get an error occurred, and then this line always runs. This one will always run whether an exception was happened or not. So if we comment these out, these error-prone lines, it still runs because the try block was executed. So both times it can run. Every single time, no matter what, the finally block will run. This is useful for when you need to clean up resources or execute code that should run no matter what else happens in your program. And you might be wondering why this actually exists, because can't you just type code immediately after the except block? Yes, you can. Typing code after the try and except like this will do the exact same thing as putting it in a finally block in most cases. So here's an example of a case where this doesn't work. Let's say you're making a function that returns a value. Let's say we're dividing a and b, and we try to set result equal to a divided by b. And then we want to return result. Then we can accept a zero division error. So this is another way to write the code we wrote in our calculator app for the zero division. So we'll return can't divide by 0. And now we will say finally. We can just print something like this will still run. As you know, return statements automatically get out of the function. They terminate the function. But even though there's this return statement, the finally block still gets executed. So here let's print the value of divide, and then we'll just divide something like 6 divided by 3. And then down here we'll do the same thing, but we'll divide 6 divided by 0. And so both times we get this still runs. So what happens in this is it tries to do this, and if it works, then it returns it. And then if it doesn't, then it returns can't divide by 0. But what this finally block does is, first of all functions return as the last thing. Returning is the last thing all functions do. So this finally block actually executes before the value is actually returned to these callers here. But the line return result was actually ran, right? It was still run, but you saw this first because you actually get the returned value last. And here's another example of using the finally block in a good scenario. So we can try to set x equal to 1 divided by 0. And here we can just accept type errors. This isn't going to throw the exception type error, but we're just going to say a type error was caught. But then in this finally block, we can print this is the end of the try except. Okay, so that's the end. And then down here, we can print this might not run. So do you want to know what this is doing? In this try over here, x is set to 1 divided by 0, which will raise a zero division error, not a type error. So this except block is skipped, but since there's no except block actually accepting zero division errors, it stops the program. But remember, the finally block will always execute. So this finally block executes before the program is done. So here we get, this is the end of the try except, and then the last thing was ran, right? So this is always going to run, and this won't because the program stopped before here. So this is useful for catching errors that are not intended. Just like I told you before about how you should always type the right error that you expect. This is useful for if you're expecting errors that you don't know what they're going to be, or that you don't even expect at all. So the code at the bottom that I deleted will not be executed because of the zero division error, because it was unhandled. We didn't handle that error. The finally block is a powerful tool in exception handling for these reasons, and using it appropriately can make your code more robust and reliable. There's one more block you can use in exception handling, the else block. An else block associated with the try except block is executed if and only if no exceptions are raised. Here's an example that includes an else block. We can try to set x equal to 1 divided by 2, and then we can accept zero division errors, so this will not throw zero division error. And then here we can type else and print everything went fine. And so we run this and it says everything went fine. That's because the zero division error was never thrown, so the else block runs. So remember, the else block only runs if none of the except statements or errors were thrown.